The water column erupts against the starboard hull. It is mid-August, 1947, late on August 16th, bleeding into the 17th. About 34 miles north of Gdansk, a massive steel shape drifts in the cold Baltic swell. There are no aircraft on her flight deck. There are no sailors in her engine room. She is 860 feet of silent floating steel, and she is refusing to die. This is the Graf Zeppelin. She is the only aircraft carrier ever launched by Nazi Germany, and today she is the subject of a secret execution. The Soviet Navy has designated her floating base, PB-101, sometimes rendered PO-101. She is a prize of war, captured not for her strategic value, but for her potential as a test subject. For 2 days, Soviet destroyers and bombers have used this empty Leviathan as a target for high-explosive physics. They have dropped a sequence of FAB-100, FAB-250, FAB-500, and FAB-1000 class bombs onto her flight deck. They have fired 180mm shells into her waterline. According to standard naval architecture tables, she should have capsized hours ago. Instead, she lists gently to starboard, absorbing the kinetic energy of a small fleet. To understand why the ship is currently absorbing a fleet's worth of ordnance, one must understand her history of deliberate destruction. Scuttling is the naval engineering practice of intentionally sinking a vessel to prevent its capture. In late March into April 1945, as the Red Army approached Stettin, today Stettin, German engineers executed a scuttling order. They opened the sea valves and detonated charges in the lower hull. The carrier settled into the shallow mud, denied to the enemy. But the destruction was incomplete. In March 1946, Soviet salvage teams patched the hull, pumped out the compartments, and raised her from the bottom. They did not raise her to serve in their fleet. They raised her to drag her out to deep water and learn exactly how much punishment a German capital ship could take. The test is methodical. The Soviet observers record the impacts. They note the deformation of the flight deck and the integrity of the bulkheads. They are looking for the breaking point of the design, but the ship is exhibiting a stubborn structural integrity that defies their calculations. The internal arrangement of the hull is containing the blast pressure, preventing the catastrophic flooding that usually dooms a warship. She is a ghost ship, stripped of her guns and her dignity, yet she is winning the physics contest against her executioners. The delay becomes a problem. The test window is closing, and the carrier remains buoyant. The Soviet command escalates to the final option. A fast torpedo craft makes the first run, and when that fails to finish the job, a destroyer is brought in to deliver the final blow. The order is given, the torpedoes streak through the water and impact the damaged hull. The explosions finally compromise the watertight integrity that bomb impacts failed to break. The buoyancy is lost. The 860-foot hull rolls further to starboard and begins the long slide toward the bottom. In the aftermath, the Soviet government seals the records. The public cover story claimed the Graf Zeppelin struck a stray mine while being towed toward Leningrad. It is a convenient lie that hides the durability data collected during the tests. The location of the sinking is omitted from the charts. The depth is unrecorded in public files. The carrier vanishes from the surface and from history, leaving only a rumor of her final hours. She descends into the dark, carrying the secrets of her construction with her. For the next 59 years, the Baltic Sea will hold a 33,000-ton secret in its crushing silence. The execution is complete, but the forensic evidence has just been deposited in the vault. By the end, the hull had taken roughly 24 direct hits from bombs and heavy shells, an outlier in any wartime damage table. Most warships of the era would have succumbed to a fraction of that energy. The survival of the Graf Zeppelin during her execution was not a miracle. It was the result of specific metallurgical decisions made in the late 1930s. The Soviet engineers who conducted the tests were not just blasting a metal box, they were inadvertently validating the quality of German armor production. That kind of survival only makes sense through target physics, the engineering study of how energy transfers into structure. This is the engineering study of how kinetic energy transfers into a structure. When a FAB-1000 class bomb detonates on a flight deck, it brings immense localized force. If the steel is too brittle, it shatters, creating catastrophic shrapnel and structural failure. If the steel is too soft, the bomb penetrates deep into the vitals before detonating. The goal of naval armor is to absorb the shock, deform without cracking, and contain the blast within a single compartment. The Graf Zeppelin was a masterclass in this passive defense. The secret to her resilience lay in a material known as Wotan steel. Named after the ancient Germanic god, this armor came in two primary variants, Wotan hard and Wotan soft, often referenced as Wotan hart and Wotan weak. The harder plates dominated the armored belt, while the flight deck and internal protection relied heavily on the softer, more ductile variant. The goal was not magical invulnerability, it was controlled deformation, absorb shock, avoid brittle cracking, and keep compartments from opening to the sea. In those trials, this material let the internal compartments take the shock waves of Soviet bombs, without tearing open to the sea. The bulkheads bowed, but they did not burst. The ship absorbed the punishment like a boxer rolling with the punches, keeping her buoyancy reserves intact long after a standard vessel would have broken her back. This durability created a unique problem for the executioners. They had intended to study destruction, but they were forced to study survival. The carrier was 85% complete when she was seized, meaning her structural skeleton was fully formed, even if her engines and guns were absent. The compartmentalization held. The watertight doors, even without a crew to shore them up, limited the flooding spread. It took the brute force of underwater torpedoes to finally bypass the Wotan armor and break the hull's equilibrium. When she finally slipped beneath the surface, she entered a new phase of existence. The Baltic Sea is a cold, brackish environment with poor visibility. The bottom composition in this region is often soft mud and silt, which can swallow a wreck and hide it from casual observation. For 59 years, the carrier lay in the dark, effectively erased from the map. The coordinates of her resting place were locked in a Moscow archive while the surface world moved on. The Cold War raged above her flight deck, fleets of NATO and Warsaw Pact ships passing overhead without realizing that a 33,000-ton giant lay beneath their keels. The silence of the deep, hostile environment preserves steel, but it also hides the truth. Without the precise location, the Graf Zeppelin was just a ghost story. Rumors circulated that she was filled with looted amber room panels or secret weapons, but the reality was more industrial. She was a fortress of Wotan steel, waiting in the heavy silence for someone to invent the technology capable of finding her. The physics of her sinking had placed her on the bottom, but the physics of sound would be required to bring her back to the surface of history. Finding a specific piece of steel in the Baltic Sea is a problem of signal to noise. The seabed is a graveyard of 2 world wars littered with thousands of wrecks, containers, and geological formations. To a sensor operator, a rock formation can look dangerously like a submarine, and a trawler wreck can mimic a capital ship. Most searches fail because the ocean is too loud and the target is too silent. But on July 12, 2006, the silence was broken by an accidental collision of sound and history. The ship involved was not hunting for lost Nazis. The research vessel St. Barbara belonged to a company called Baltic, and her mission was purely industrial. Her crew was scanning that same stretch of seabed, looking for geologic structures that might indicate oil or gas deposits. They were dragging sensors through the dark, mapping the subterranean layers. Then, the instruments registered a massive anomaly. It was not a rock, it was a geometric structure rising nearly 90 feet from the bottom. It was too large to be a fishing boat and too solid to be a natural formation. Baltic notified the Polish Navy. The Navy dispatched the survey ship ORP Arktowski to investigate. The Arktowski is a specialist vessel designed to map the underwater environment with high-resolution acoustics. When her crew arrived at the coordinates, they did not drop cameras or divers. They deployed side-scan sonar. This technology is the primary tool for deep-water forensic work. It works by towing a sensor fish, or tow fish, behind the ship. The fish emits pulses of high-frequency sound to the left and right, sweeping the floor like a flashlight beam in a dark room. When the sound wave hits a flat bottom, it returns a uniform signal. But when it strikes a vertical object like the hull of a shipwreck, 2 things happen. First, the object reflects a hard, bright return signal. Second, and more importantly, the object blocks the sound from reaching the seafloor behind it. This creates a zone of acoustic silence. In the trade, this is known as a hydrographic shadow. The sonar operator does not see the ship directly, he sees the absence of sound behind it. By measuring the length of this shadow and knowing the angle of the sonar pulse, the operator can calculate the height of the object with trigonometric precision. On the screens aboard the Arctovski, the image began to scroll. The return signal painted a bright white line of hard metal, followed by a long, dark shadow stretching across the digital seabed. The shadow was immense. It revealed a continuous structure over 800 feet long. The geometry was unmistakable. It was a flat-topped vessel with a massive displacement. Inside that shadow, the wreck began to give up detail. It showed a superstructure offset to the starboard side. It showed a flight deck that ran the entire length of the hull. The data stream confirmed that this was no ordinary merchant vessel. The sheer scale of the target eliminated almost every other possibility in the Baltic registry. The Polish hydrographers realized they were parking their ship directly above a lost giant. The anomaly found by the oil surveyors was a heavy warship, lying quietly in the shipping lanes. The digital resurrection had begun. The sonar had stripped away the cover of water and revealed the shape of the ghost. But a shape is not an identity. To prove this was the Graf Zeppelin and not a different Leviathan, the Navy would need to analyze the specific damage signatures hidden within the acoustic data. The survey phase was over. The forensic phase was about to begin. The geometry of a shipwreck is rarely neat. Most vessels that sink in combat arrive on the bottom as debris fields, their hulls shattered by magazine explosions or crushed by the hydrostatic pressure of the descent. The object lying 285 feet down in the Baltic Sea is different. It is defiant in its cohesion. The sonar images reveal a hull that has refused to disintegrate. It lies on a hard angle, listing heavily to starboard, but the spine of the ship remains unbroken. At this depth, the water exerts roughly 10 atmospheres of pressure. It is an unforgiving load on any trapped void space, yet the carrier remains recognizable. This survival is due to a fundamental naval architecture principle known as compartmentalization. In a warship design, the interior is not a hollow cavern, it is a honeycomb. The hull is divided into hundreds of smaller, watertight cells by vertical bulkheads and horizontal decks. This design is intended to limit flooding during battle, ensuring that a torpedo hit floods only a few cells rather than the entire ship. On the way down, the wreck flooded and equalized as it sank, so it did not collapse into a flattened debris field. That internal grid kept the outer plating and the Wotan steel skin supported, preserving the hull's overall shape against the crushing load of the water column. The Wotan steel skin remained supported by the internal grid, preserving the ship's shape against the crushing weight of the water column. The wreck is not a flat pile of scrap. It is a three-dimensional monument to German welding and structural engineering. The sheer scale of the hull creates a logistical problem for the survey team. An 800-plus foot target that refuses to fit inside a single clean, high-resolution pass. Standard side-scan sonar equipment typically scans a swath of the seabed, but the target here is so massive that it exceeds the width of a single high-resolution pass. The operators must stitch together multiple acoustic runs to build a complete mosaic of the wreck. As they assemble the digital image, the starboard list becomes the defining feature of the site. The ship rests on her keel but leans over, driving that armor belt into the silt. This orientation is consistent with the loss of buoyancy on the side where the Soviet torpedoes struck. Down at roughly 285 to 300 feet, the wreck sits in the deep hostile. Permanent darkness, near-freezing water, and corrosion that moves slowly, not kindly. The low oxygen levels in the Baltic can delay the rust, but they cannot stop it. The flight deck, once designed to launch Messerschmitt fighters, is now filmed with fine sediment. Above it, the island superstructure rises out of the gloom, tilted at a precarious angle. Despite the preservation, the identity of the ship is strictly speaking still a hypothesis based on dimensions. The Baltic Sea is large, and the Soviets were active in this region for decades. To move from a high-probability target to a confirmed identification, the forensic team needs more than just length and width. They need a fingerprint. They need to find a specific wound on the steel carcass that corresponds exactly to the secret records of the 1947 execution. The structural integrity has proven the ship was a capital vessel, but the damage will prove her name. The evidence does not fit the lie. For decades, the official story was simple: a stray mine under tow. This cover story was convenient for the Soviet Union, as it concealed the secret weapons tests and absolved the Navy of needing to explain why they sank a valuable prize. But a naval mine leaves a specific signature. It detonates against the lower hull, blowing a jagged hole inwards and venting pressure upwards through the ship. The sonar images scrolling across the screens of the ORP Arctovsky tell a completely different story. The most damning piece of evidence is located amidships at the site of the island superstructure. On a carrier, the funnel is a prominent feature, usually integrated into the island to vent exhaust away from the flight deck. On the digital mosaic derived from the sonar, the funnel of the wreck is not standing. It is crushed downwards, collapsed into the steel structure below it, as if struck by a giant hammer from the sky. This damage is physically impossible to achieve with a mine. A mine strikes the keel. It does not crush a smokestack located 80 feet above the waterline. This contradiction triggers the process of forensic matching. This is the technique of correlating physical damage on a wreck with historical documentation to achieve a positive identification. The Polish Navy analysts turned to later released Soviet-era records and secondary summaries of the trials. These documents, the PB-101 logs, describe the 1947 execution in granular detail. One entry stood out. It described a test meant to simulate the detonation of a FAB-1000 class aerial bomb in the exhaust funnel, collapsing the uptake into the superstructure. The image on the sonar screen is a perfect digital twin of that written record. The crushed funnel is not random debris, it is a forensic fingerprint. It confirms that the damage came from above, not below. It links this specific pile of steel at the bottom of the Baltic Sea to the specific bomb dropped on that August afternoon in 1947. The probability of another ship of this size having this exact damage profile in this exact location is 0. With this match, the mine strike cover story is definitively debunked. The accident was actually a calculated structural test. With that match, the last doubt burns away. The massive object leaning to starboard is indeed the Graf Zeppelin. The mystery of her vanishing is solved not by finding a nameplate, but by analyzing the violence inflicted upon her. The confirmation brings a strange sense of closure to the team aboard the Arctovsky. They have not just found a shipwreck, they have corrected the historical record. The ship was not a victim of a random hazard. She was a gladiator that died in the arena, absorbing punishment that would have pulverized a lesser vessel. The shattered funnel is a badge of that endurance. The match is absolute. The ship that hit the bottom in 1947 has been officially reconnected with the ship that appeared on the sensors in 2006. The survey has achieved its primary objective. The ghost has a name. The discovery of the Graf Zeppelin resolves the mystery of her location, but it opens a new chapter regarding her legal and physical status. The wreck lies roughly 34 miles north of Gdansk, well within the exclusive economic zone of Poland. While the coordinates are now known to hydrographers, the site remains under a shadow of restriction. It is not a tourist destination for technical divers, nor is it a resource for scrap metal scavengers. It is protected by a complex intersection of history and maritime law. A commonly cited principle here is sovereign immunity. Many states treat sunken naval vessels as protected government property. But the Graf Zeppelin sits in a complicated corner case, built by Germany, taken as a war prize by the Soviet Union, and lying today inside Poland's exclusive economic zone. In practice, access and any disturbance depend on overlapping national claims, permits, and diplomatic agreement, which is why the site remains effectively sealed. This legal isolation preserves the irony. Germany's only launched carrier never fought a war. She was approximately 85% complete when the war ended, but she never commissioned. Her hangars never housed an active air wing. Her catapults never launched a fighter in anger. She was a weapon built for a conflict that ended before she could participate, leaving her to serve only as a mute victim for weapons testing. However, her legacy is not one of total failure. The 1947 tests and the 2006 survey that confirmed them prove a significant point about naval engineering. The ship was designed to be unsinkable by standard means, and she largely succeeded. It took an overwhelming, calculated effort by a foreign navy to put her on the bottom. The V-10 steel hull did not fail due to a design flaw. It failed because it was subjected to an execution squad. Today, the wreck serves as an artificial reef and a silent monument to the Kriegsmarine's ambition. The marine life of the Baltic has claimed the flight deck where Stuka dive bombers were meant to land. The silt is slowly bearing the armor belt that frustrated Soviet engineers. The risk of oil leakage or environmental contamination is not well documented in public sources. Whatever remained aboard was likely far less than an operational fueled warship. But the true condition of tanks and residues is unknown. She is a benign giant resting on her starboard side, slowly dissolving into the geological timeline. The file on the Graf Zeppelin is now closed. The rumors of secret cargo have been silenced by the sonar data. The theories of a mine strike have been disproven by the crushed funnel. The ghost ship that vanished in 1947 has been found, identified, and cataloged. She remains the only testament to a naval strategy that never materialized, a solitary steel island in the deep hostile, guarding nothing but the silence of the sea floor.